We're talking about parabolas. We talked about the concept. Ms. Stuckey, if you would get your pencil in your hand and move your purse so we can begin this lesson. Thank you kindly. We're going to talk about parabolas. We talked about the concept. We talked about them being horizontal, vertical. We talked about being able to look for the vertex, focus, axis of symmetry, the directrix, and the max and min. These were the two formulas that we talked about using, and the letters that we were going to kind of be working with were H, K, P. We're not going to work with A so much right now. We'll work with A maybe Friday, and of course X, Y, F, D, and B. I have these videos and they're being loaded to YouTube, and I would encourage you. I would strongly encourage you. For example, this is block 5. I will label this video as block 5. So you will know, oh, okay, I saw those examples. If you want to see more examples or different examples, go and look at blocks 2, blocks 3, and blocks 4. Okay? Typically, as we get this started now on YouTube, I will be doing different examples in different classes, which will give you a variety of problems. It will give you more than what you just see in your own block 5. Okay? Does that make sense? Okay, so it will be labeled as block 5. I would also encourage you to, if you're absent, look at the video, take some notes, and that way when you come back to class the next time, you're not totally cold to what we were doing when you were absent. Does that make sense, class? All right, very good. Okay, and I would also encourage you, yet and still, go home and look at the video again and try to write the problem down, and before I start to work it, you actually put it on pause and you try to work it. That's called studying, right, class? Okay, that's going to allow us to move forward and be ready for 10 Ready in May. Is that right, class? Okay, all right. So again, we're talking about this is called transformational form. Okay, if you look at our objective board over here by Chris, it does say transformational form, and it gives these two types of equations that we're going to work with for our parabolas. So let's just go ahead and dive in and start working these problems right here, these 5 problems. Okay, so our first problem is x minus 3 quantity squared, and that equals 12 times the quantity of y minus 7. So step 1, we really want to find out which equation we're working with. Would that be 1 or 2? I agree. Equation 1. Can somebody tell me, can you tell me why we would like to use equation 1? Versus equation 2. Caleb, would you like to help her? I'm speaking to Caleb, class. Move your hand. I can't hear you, Caleb, sir.
A variable, or because it has the 2 of them squared.
Okay, I'm gonna let Shantika add something to that. I like that, but let Shantika add something to it.
Okay, the first one, the way it's set up is similar to the problem. So it's like x minus h squared equals 4p y minus k, and it's similar to that.
Okay, I like what you said as well. I'll let you add something to it, Mr. Redmond.
You gotta use it because the quantity of x minus h, the quantity of the squared power, is set up. Like the square is on the x. That's what I'm trying to say.
Okay. All right. All 3 of you said the same thing, and to be honest with you, it started with Caleb. It built up more with Shantika, and of course, Mr. Redmond brought it home by simply saying the quantity x minus h is squared. That quantity is squared, and in this case, that's what we have in this one. The x minus h, that x quantity is squared. Okay? So we're going to write this one above it. X minus h squared equals 4p times y minus k. And with that, we want to talk about let's talk about the concept of what's going on with that quantity being squared, because that's very important. When we go over here, and we're going to just draw us a little graph. So let's just draw x squared right here. Beside the x squared, we're going to put our little coordinate plane, our little rough sketch. And if I had a negative, or what if I had a positive 4 and I squared it? What would I get? What if I had a negative 4? what would if I squared it, what would I get?
16.
So, because my x is squared, I will have these two quantities along one of these x values, and so I know my graph would have to open what?
Up or down?
Down or what? Up. Okay? Do you all understand that? Okay? And we'll see if we'll do one with the y in just a moment. Now, what I want to talk about is now we need to know if it's going to open down or up. What tells us that?
The sign.
I heard, you know what I heard? I heard the P and the sign. I like that, okay? Because we are going to focus on this part of the equation right here where we have 4P. So it would be the sign of this value here once we actually analyze that. So let's go ahead and do that. So we take our 4P, set it's equal to 12, and we divide both sides by 4. P equals 3. It's positive. So because 3 is positive, write the word positive in your notes, our graph will open up. Because 3 is positive, our graph will open up. Well, that's not everything, Miss Stuckey, right now. First, we got to actually graph it. But we have enough, we're getting information in order to graph it. Okay? So in order to graph a parabola, we know the thing about a parabola is it's this U shape, right? And it has a turning point. What is that turning point? When that graph turns, it starts out and then it turns, or it starts out and then it turns, or it starts out and then it turns, or it starts out and it turns. What is that turning point called? The vertex, right, Miss Anderson? So we need to go ahead on and plot our vertex. And our vertex is H, comma, K. So for this problem, it's going to be what, class?
3, 7.
A positive 3 and a positive 7. I agree. 3, 7. So we graph that. We go 3 on the X, 7 on the Y. Okay, that's our vertex. What's the next step we need to take, class, in order to graph this?
We need to find our focus.
We need to find our focus by using P. Okay? So, here's one of the things. We found this. We found our vertex, right, class?
Yes.
So now let's find our focus. We have our P value, right? So, what do I do with this value of 3? So we can find the focus.
You have to add it to
I add it to the HK. How? Which way? Okay. Right now we're actually going to do a problem. So now I want you to tell me where I go on the coordinate plane to add that 3. Okay, I heard up and I heard over. Which one is
You
it?
go over the graph going like this. So you got
I'm hearing over.
it's
Up or over?
It's up because the graph is going like this.
Open it up.
It's a U shape going.
Okay, for babies who said over, that's not correct. We're actually going to go up. We're going to go straight up with the vertex. And the reason being is because our graph is what? And it opens what? So we know that the graph will look something like this. So the focus always has to be on the inside or the outside of the parabola?
Inside.
On the inside. On the inside. So we go up 3. Okay, so this is V for the vertex, and that's F for the focus. Right, class? Okay, right now we're just going to do a rough sketch, but later I'm going to actually have you do it very accurately. Okay? Just for the record, I'm actually going to have you give me the correct y-intercept. Or I'm going to ask you to give me x-intercepts if there are any. Okay? Or y-intercepts if there are any. You're actually going to have to calculate those. Okay? Alright. So right now we have the vertex and the focus. So we know that from the focus to the vertex, I'm going to ask someone. Hey, Robin, what is that red distance? That line, okay. The axis of symmetry does go there, but that's not what I'm asking. I'm only asking for this distance from here to here. How much is that red part? Okay, Robin. You want to help him out, Gabriel? Of course it's
It is
3.
3. I'm confident.
Okay, so what we're saying is, Kairobi, is that the distance from the vertex to the focus is this value. That's why we got the value. We needed that to tell us where to go. Okay, all right. It's kind of like the percussion section typically might be in the center of the band, and they might be at the 50-yard line, and of course then your horns might be located at the 45-yard line. You understand? So that distance between the percussion and the horns is 5 yards. So this distance from the vertex to the focus is P distance, which is 3. So with that said, Miss Rochelle, where would I find my directrix? I can't hear you, ma'am. What little line right there? Be a little bit more specific, Miss Rochelle. The red line. Okay, what do I do with that red line? I am going to grab it, but again, I need you to be specific. Okay, I can put the red line over here. I mean, I can put the red space. I can put that little red space over there. I can put it over here. Where do you want me to put it? You want to help her out, Ciaga? You done? Okay. Miss Catwin, you can help her out. How would I find my directrix? See, I know all of you. Okay, first of all, class, the reason I'm asking, I'm cold calling you. You know what cold call means? Where I just randomly call you? Because you have lots of notes. Because you remember the homework assignment that you did? Yes. So I know that you did that homework assignment, and you, out of those 8 problems, 6 of them were like this. So remember, as we flip our classroom, we should be able to answer some general questions. Not specific, but some general questions. So I'm going to go ahead and let Mr. Redmond handle it before his arm falls off. So Mr. Redmond, can you tell me how I can find, tell me and your peers how we can find the directrix?
You have to take the Y, minus by your B.
Okay, so he said we're going to take this Y here. The Y where?
The Y on
Okay, Gabriel said on the vertex, and we're going to take away P from that, right?
yes, ma'am.
We're going to come down P distance. So what would we come down to?
4.
What would we come down to, class?
4.
Okay, what is my Y distance on the vertex?
7.
What distance am I subtracting?
3.
So what is 7 minus 3?
4.
Okay, so then my directrix will be, somebody tell me what the equation is?
Yes,
X,
no, it's Y.
Y equals 4. Yeah, it's on the Y.
Y equals, exactly, Y equals 4. Now, I also want to go ahead now and put in my axis of symmetry. It's an equation. What is it?
X equals 3.
X equals 3. Very good, class. And so I'll go ahead on and just put, actually I want to put my great distance here. This is also 3, which is the p-value. And of course my axis of symmetry is X equals 3, and my directrix is Y equals 4. And of course the vertex and the focus are, oh, so I gotta write the focus. What is our focus, class?
3
What is focus?
3
3 comma 10. Why did you say 3 comma 10, Gabriel?
You went up 3 and it ended up on 10.
Okay, so our x value in line with the vertex is 3, right? Everybody agree with that? But we went up that p distance, right?
Yes.
So our y value changed, right?
Yes.
So our y value was 7, but when we went up 3 on the y, it changed to what?
10.
7 plus
3.
is...
10.
Alright. Okay, let's talk about a couple other things that I am going to ask you for. I want to ask you for the domain and range. Okay? We need to know things about the domain and range. Well, first, I'm sorry. Let's go check off our list over here. We got the axis of symmetry directories. What else do we need? Max and min. What do we have a max or a min?
Minimum.
No, it's a min.
It's a minimum.
How do you know that?
Because usually it goes up, so it's at the bottom.
It opens up.
The vertex opens up to the point.
Okay. And the vertex is the lowest point on the graph, right? Okay, it's the lowest point on the graph. So let's quickly write the domain and range so we'll know how to do that. So our domain for this graph, what would it be, class?
X.
What is the definition of domain?
All
All possible x values. So what, for this black parabola here, what are the possible x values that it would take on, Miss Stuckey? Miss Kennedy? What x values? Do you see that graph taken? Mr. Gary? Okay, there has to be some other values. Okay, I think you got things switched around. Switch it back around. Okay, Moses?
Can't you write something like positive?
Yeah, but you all are not giving me the full definition. Remember back in the
So
day
X,
when we did domain and range back earlier in school this year, or we put our little squiggly breaks?
yeah, it's bracket.
Okay, everybody repeat after me. X, such that, X is contained in
It's contained in
all real numbers.
all real numbers.
This is in your notes.
Yes, it is.
Okay. All right. Now, there's another way we can write it. We can write it as negative infinity is less than x, and x is less than positive infinity. We can also write it as, everybody say soft. Soft bracket, negative infinity, comma, positive infinity, soft. How do we write the range?
Bracket. Y. Bracket.
Say again?
Bracket.
Well, let's write it in set builder notation first. No, put the little curly brace there. Put our brace. Everybody say Y. Such that. Y. Finish it for me, class.
All real numbers.
I don't think Y is going to take on all real numbers because negative 10 is a real number, but this graph does not take on negative 10 as a Y value. So it's not going to take on all real numbers. What would we write? It's going to be greater than or equal to what, class? 7. Because we know our graph, the lowest point of the graph is at 7, which is the Y value from our vertex right there. Okay? So this graph will not touch Y equals 6, Y equals 0, Y equals negative 4, none of that. The lowest point on that graph, the lowest point is 7, so we have this as our range of values. Or we can write it as, everybody say, hard bracket. 7, comma, infinity, soft bracket. Okay. All right, very good. Okay, go ahead and line up your paper. We're getting ready to do problem number 2. Problem number 2. We're going to write it down because what are we going to write above it?
equation.
One of those general equations that we're going to use. So this one we have y, the quantity of y minus 4 squared equals 20 times the quantity of x plus 2. Okay? Which one are we going to use?
The
Second one.
So it reads the quantity of y minus k squared equals 4p times x minus h. Okay, we want to get our checklist, okay, class? We need to get our checklist, but we also have to understand the concept. Everybody say concept.
Concept.
So again, what's the first thing we need to focus on? We know which equation we're going to use. What do we want to focus on as we begin to do this? Okay, so you all want to go ahead and write the vertex? That's fine. We can go ahead and do that. But again, there are some things we need before we get other things, and we want to understand how to move through it. So you want to write the vertex? That's fine with me. What is our vertex, class?
2 and negative 4. Negative 2
82 positive.
Okay, class, you're going to have to be careful. You got to get the H first. The vertex is always H, comma, K. This is why I ask on your paper that you actually write all of this, the formalities. Don't just write the problem, because you get home to study and you don't realize, oh, I need to use this particular equation, or I don't know where to start. When you get home and begin to study, you need to write HK so that you go over here and get HK. And in order for you to get HK, because I heard some incorrect answers, what are you all saying it is?
Negative 2.
It's negative 2, comma, positive 4. So again, write it so you can be familiar with the fact that it is HK, because they are on opposite sides. It depends on which problem, which equation you use. So if I go negative 2 on the X and up 4 on the Y, okay, then I have this. Now, I'm at home. I don't know what to do. Where do I go from here? Here's the thing. We know we want all of these items. This is our checklist of things that we need.
You gotta find your P.
Y'all want to find P?
Yes.
Okay, well, let's find P then. So we're just going to write down the things that we have. 4P equals 20 divided by 4 equals 5. So what does that tell me? It tells me that P equals 5, but what does that buy for me? What does that tell me in terms of, all I have is a dot right here and I need to graph.
It's opening up.
It's 5 positive, opening up.
So because it's positive, you're saying that it's opening up, right? Because P is positive, right? But that's a true statement, but that's not all the way true.
It tells the direction to go how it's going to go from the vertex.
It's open to the left.
It's really helping you find your focus.
Yeah,
It does. He does help you find your focus. But the thing is, here's the catch. It may not always open up.
You know, I'm talking about it go to the left. Yeah. It's the horizontal one.
How do you know that?
Because I wrote down yesterday.
No. Well, unfortunately, on the 10 ready test, you cannot take in things that you have written down. So how are you going to tell yourself in your mind?
If the y is squared, it opens left or right.
If the y is squared, it opens left or right. And Miss Stuckey, if you would open your eyes, you would see that the y is indeed squared. Now let's talk about how we're going to do it on the 10 ready test, okay? Here's what you're going to say, because you will not have your notes. Here's what you need to put in your mind. You need to tell yourself that if the y is squared, you need to actually draw it out. Draw it out, class. If that y is squared, draw it out. If I have a positive 4 and a negative 4, they both are going to give me a 16, right? And because my y value is squared, I know that my graph has to open what? Not up or down, but left or right. So this graph is not going to open up or down. It's going to open left or right. Now, because I know that P is positive, I know it's going to open which way? To the right. So I curve it here. Now I can go 5 and do my focus. I can go add 5 for my focus, go back 5 for my directrix, and we put my axis of symmetry in, and we are just so done. So let's do that. So now we have our vertex. let's go ahead and put in our focus. So we're gonna go 5. I have to go 1, 2, 3, 4, 5. 1, 2, 3, 4, I'm sorry, 5. There we go. So, can anybody tell me the coordinates of my focus?
It should be 3 and 4.
The matrix is gonna be
No, I'm with the coordinates of my focus.
Either 5 and 9.
5 and
3 and 4.
Okay, I want you, okay, everybody say, be careful.
Be careful.
Class, you can't just say because we went a distance of 5 that 5 is going to be a part of your focus. Okay? You actually have to recognize this. Number 1, we started.
You started at 4.
Where's my yardstick, class? Hand me that one, Miss Patton. Hand me that. Is my yardstick back there, Katie? Let me have that. Thank you. Class, you have to pay attention to the fact that we actually started at -2 right here. Okay? I know everybody's kind of leaning to the side. But anyway, we started at -2. So if we start at -2 and we add 5, we have to go 1, 2, 3, 4, 5. Okay? So we are going 5. I stopped right here at 5. But actually on the coordinate plane, on the XY plane, this is 0, 0, and that's 1, 2, 3. So it's gonna be 3, 4. You can't put a 5 there arbitrarily. Yes, we went a distance of 5, but we started 2 behind 0. We started at what? -2. Do you understand that? So, okay. And you need to understand, let me tell you why you need to understand this. Because the next time I'm going to give you a focus and a vertex, and you're going to have to write the equation. You're going to have to write the equation, but it's fairly simple, yes. Repeat this again. Okay. We know that you understand about the opening of the graph, the concept of the opening. You understand that it opens to the right because P is positive. So we know that our vertex is at -2, 4, correct? So my vertex is right here at -2, okay, on the X, for the X values. So I know my focus has to be inside the parabola because that's the microphone on the inside of the parabola, right? So I'm going to go here. So I'm actually going to count. If I start here, then I'm going to count 1, 2, 3, 4, and 5. That's that 5 right there. But I actually have to understand that this is the XY coordinate plane. In the middle is 0, 0, right? So if this is 0 right here, if that's 0, that's 1, that's 2, that's 3, that's -1, that's -2. So I'm actually at 3. I'm not at 5. I went over 5, but I'm actually at 3 for the X. You see that, Rochelle? You see? So I'm actually at 3. Now, and then I have to go up 4 so that I can be in line with the vertex. So that's why I'm at 3, 4. Okay? All right. Now, remember when we talked about the concept? We talked about K plus P and K minus P and so forth. Okay? If you take, in order to get a positive 3 here, our K value is, I'm sorry, well, this one would be a K, this one would be the X. A -2 plus 5 will give you what?
3.
So this would be our, instead of our K, this would be our H plus P. So that's what we talked about on the concept. Because remember I told you had to take this, we're looking at this H value, which is our X value, which is -2. And remember I told you we're going to add P, and then we end up at 3. Okay? All right. Okay. All right, now, so we have this. So now we need to go back 5 in the other direction so we can get the directrix, right? Okay, so let's go ahead and open up our parabola. Once again, I will make you draw them accurately because we're going to calculate additional points. And when we calculate additional points, remember TI?
You can have whatever you like.
X and Y can be what? Whatever you like. Okay. when we draw them accurately. But now, let's just go ahead and get the directrix. So I'm at -2, so I want to come back 5. Okay, I came back 5, right, Rochelle? Okay, so let me put my 5 here. So 5 here. 5 here. So I draw my directrix. What is the equation for my directrix, class? You sure about that?
X equals
X equals what, class? But put some numbers on your graph if you're not sure. Just number that number line. Just number that X number line and tell me what it is.
X equals -7.
Yeah.
It's -7. Remember we talked about adding and subtracting? So if we had a -2 and we subtracted 5, where would we be at? There's your H minus P. Put that in your notes, class, so you need to know. There's your H minus P. It would be a -7. Okay, let's talk about the domain and range very quickly. Oh, no, I'm sorry. What are we missing on our checklist? The axis of symmetry and the max and min, right? So what is our axis of symmetry?
Y equals 4.
What is it, class?
Y equals 4.
It is. Now notice, the axis of symmetry is, somebody tell me what the P word is. I'm going to do it. I'm going to draw it from geometry. Not parallel. Perpendicular. Perpendicular. Forms that 90-degree angle from geometry. So the axis of symmetry is, what is the equation?
Y equals 4.
Huh?
Y equals 4.
Y equals 4. Now, what I need you to notice, because they are perpendicular, notice. Miss Stuckey, would you sit up, please? Miss Sheard, also, would you sit up in your seat and pay attention to the notes? So the directrix is X equals -7. The axis of symmetry is Y equals 4. Notice, this one is X, that one is Y. Okay? They're running in different directions, right? Directions that are where they're parallel to one another. Yes. I'm not parallel, perpendicular. Sorry, y'all. Perpendicular to one another. Okay, let's do the domain and range real quick. Okay. Let's do the domain and range, and then I'm going to let you work some problems. So what is the domain, class? I'm going to have to write and squeeze it in here. What is the domain? Come on. Help me out.
The domain.
X such that X contained in? Contained in what? All reals?
No.
I don't think so. I don't think this graph is going to touch all X values.
From greater than
Pardon me? Not -7. Who said it? Okay, what do I do with the -2 though? Greater than or equal to -2. Very good, Alexis. Okay, do you all see that? Will my graph touch, will this actual graph touch -10? No. No. Okay? Actually, we didn't do the max and min. What is the maximum value? Let me ask you, do we have a maximum?
You just told us.
That's a min.
But I said min.
Come on, class. Well, tell me how it's a max thing. Oh, tell me how it's a min, how you think it's a min, so I can, if you understand.
I was thinking like a min.
I see that. I couldn't, and that's what I was thinking. But I can see your thinking. It's actually, this is, I'm sorry.
It's a minimum.
It is a minimum. It's a minimum. But it's not because of the negatives per se.
Yeah.
Because the graph could be shifted over here. It's just the lowest value on this X number line. All the other numbers get bigger. Okay? So yes, it is a minimum. But not because of negative. You understand, baby girl? What I mean is, let me draw it somewhere and then I'll erase it. What I mean is that the graph could actually start here. It doesn't have to start in the negative, Shantika. It can start over here at 4, It's just that the lowest value would be what? 4. It's not negative, but the lowest value could be what? 4. Okay. All right, so that's the domain. What's another way to write this, class? No, hard bracket, -2, comma, infinity, soft bracket. Okay, now how do we write the range? I'm gonna have to erase something. I'm gonna have to erase this information to write the range. I'm gonna write the range beside. How do we write the range? Come on, y'all. Y such that Y
is let's greater than equal to.
Y is gonna be greater than or equal to what? Tell me what it's gonna be greater than or equal to.
4.
Okay, this graph will be greater than or equal to 4. Okay, that part. There's also a part down here. It's going to be greater than or equal to 4 for sure. I just highlighted that with this black marker. This graph will touch Y values 4 and above.
And then
But this graph goes down here.
no, it's not.
Babies. All real numbers. This graph is going to touch all Y values. Because it's going to keep going. It's going to get wider and wider and wider and wider. And it's going to touch all Y values. All those real numbers, okay?
Yes.
Okay? Do you all see that? Do you know it's going to get wider? You know that parabola's going to get wider? Okay. All right, now, so we can also say negative infinity, right? It's going to be less than Y. And Y is going to be less than positive infinity. We can also write it as negative infinity comma positive. Okay? All right, now, I'm challenging you right now, get out a clean piece of paper. I need you to turn in 3 and 4 before you leave. You may use your notes.